in this question here, we have question number 1.1, which talks about the stable weather conditions over the interior of South Africa are due to the well-developed high-pressure cell. Right, for us to realize stable weather conditions over the interior of South Africa, we understand that stable weather conditions are realized when we have the dominance of sinking air. When we have a sinking air, that is where we have fine weather, we have stable weather, which is an anti-cyclonic system. So in this instance here, over the interior, when we are having stable weather conditions, we are having the dominance of the Kalahari high pressure cell. So for that question there, our correct response would be the item number D, which is the Kalahari high pressure cell. It's the one that contributes towards fine weather conditions over the interior. Right, we move on to the second question. Right, the dew point temperature at weather station A, if we check weather station A, you tend to find that weather station A is located here, there over the interior to the extreme west, close to the extreme west coast. So the dew point temperature, we are talking of the presentation of temperature on the synoptic weather map. We have two temperature readings, the one on top and the one at the bottom, meaning to say we have the air temperature, which is the maximum temperature, and the dew point temperature, which is the minimum temperature. So we take the least one, the smaller between the two, which means that is the negative 8 degrees Celsius. That becomes our minimum temperature, or our dew point temperature for that weather station. So our correct response in that question becomes response number item B, which is negative 8. Right, we move on to the next question, which is question number 1.13, which says the atmospheric air pressure at weather station B is dash hectopascals. Right, we try to check again on our synoptic map. We are seeing that station B is located here, and for us to figure out the pressure for this particular weather station here, it's not indicated for us. We need to use map interpretation skills. Right, we check the isobars closer to that station. Right, if we check our isobar here, we have an isobar with a reading of 1016 hectopascals, and we have our station B as we go to the north eastern direction. We also see that we have another isobar which crosses via this path here, which has got a reading of 1020. So if we check here our isobaric interval, it represents that it has a 4 hectopascal interval from 1016 to 1020, 1016 to 1020. That is a difference of 4 hectopascals. So if we can try to estimate before we even check on the responses, our response definitely has to lie within the range of 1016 and 1020. It should be between the values of 1016 and 1020, which will mean that it can only be 1017, 1018, 1019. Those are the possible responses for that particular station. So if we try to check on our responses here, definitely there's no response which coincide, or which is there are no two responses which definitely fall within the range of our responses expected. So the correct answer for that question comes as response number C, which is 1018 hectopascals for that question. Then we move on to the next question, which is question number 1.14, right, which talks about the low pressure cell at C is known as a dash low. Right. We go to our synoptic map and try to identify C. Our C is here. Right. If we see the location of our pressure cell there, we can actually see that the pressure cell is located along the coast, is along the coastline. And if you check on this extreme western side, we are over the Atlantic Ocean, and as we get to the eastern side, we are getting inland. So this low pressure cell is along the coast, is along the coastline here. So low pressure cells that we tend to find along the coast, we call them the coastal low pressure cells. So we check on our responses, and on our responses, the correct response there becomes a coastal low for that question, which means our item number D becomes the correct response. Right, we move on to number 115, which says the type of precipitation found at town D is dash. Right, we go back to our map and try to identify where town D is. Right, we check there, our D is there, indicated by this letter, and is pointing to that symbol there. Right, what does that symbol mean? What is the type of precipitation indicated by that symbol? You can see D is pointing at a dot. Right, we have several symbols that are used in synoptic weather maps. We have symbols for different types of precipitation. We have symbols for fog, symbols for mist, symbols for hail, drizzle, rain, whatever form of precipitation, snow. They have different ways of presentation on the synoptic map. So for this one, for this dot here, the correct response is rain. That is the type of precipitation that is represented by that symbol on the synoptic map. So we check the response of rain. Right, we go to the next question. Right, the type of precipitation, to answer question number 1.15, is caused by, right, what causes the rain is, we want to look for the first item of the type of winds which will cause that type of precipitation. Definitely in that instance, when we talk of offshore and onshore winds, we are looking at offshore, we are looking at winds which are coming from land going over the water body or going over the ocean. And onshore, we are looking at winds which come from the ocean over the land. So definitely for us to have rain conditions, we need to have onshore winds. So we pick our item number 2. Then we look at the conditions of the winds which are onshore, conditions which are likely to cause rainfall. For us to have effective condensation taking place, we need to have warm and moist air. Cold and dry air has no capacity here to cause condensation, because if the air is dry, it means it doesn't have moisture. So we cannot have effective cloud formation, and we cannot have rain formation. So in this instance, our item number 116, the correct response you are picking the response for onshore, and you are also picking the response for warm and moist, which gives us a combination at D with item number 2 for onshore and item number 4 for warm and moist, which gives us the response item D for that response for question number 1.16. Then we proceed to question number 1.17. Right, the evidence of backwind conditions at weather station E is dash and dash. We need 2 conditions that suggest that there was a backwind on that particular weather station at E. Let's try to figure out from the station E. If you try to figure out a station E, you can see that the conditions there is clear skies. If you check there is no shading to indicate cloud cover on that station. And also if you check, the wind direction is a north-westerly wind. And if you also check the temperatures, the maximum temperature is 27, the minimum temperature is -9. So if you try to figure out on these conditions here, we want to figure out conditions that relate to the prevalence of backwind conditions on that weather station. We have noted that there is clear sky, there is no cloud cover here, and we have also noted that the maximum and minimum temperature is 27 and -9, and also the wind direction is a northeasterly or northwesterly wind and at 30 knots. Right. So if we go to our responses, we want to try and figure out the conditions that are most likely to have caused the wind, the conditions to be having back winds. Right. Clear skies, we have noted that the weather station is resembling clear skies. There's no shade, which represents any form of cloud cover. It's a valid response. General winds, we cannot talk of general winds. We have seen that the wind speed was at 30 knots, which is not general in that instance, which means the response item number 2, we are phasing it out. Then we also talk of a large temperature range. If you see the temperature range on that weather station, we had a minimum of -9 and a maximum of +27, which resembles that there was a very big temperature range. There was a very wide temperature range of 36 degrees Celsius. And the implication is such that the conditions before the coming of the back winds, it was extremely cold with a temperature of a minimum of -9, and then with the coming of the back winds, the temperatures rose from that minimum until they got to a higher temperature of 27 degrees. So a large temperature range is a possible response. Then southeasterly winds. The wind direction, we've seen that is not even a southeasterly wind, so we are phasing out the last response. So the remaining response is clear skies and a large temperature range, which gives us a combination of item number 1 and item number 3. The combination falls at option number A, which is the correct response for that question number 117. It gives us the response at A. Right. That was question number 1.1. Then we proceed to item number 1.2. Basically, it's a question which is based on urban climates. Right. And before you figure out the questions, we need to familiarize with the concepts of urban climates and how the climate conditions are modified by the urban environment. Because you remember, an urban climate is a micro climate, which means it's a unique climate for a particular geographical region, for a particular smaller geographical space, which is an urban setting. So there are different factors that shape and that determine the climatic conditions that are realized in an urban settlement. Right, now let's look at the questions. We got question number 121. Slopes in a valley facing the equator are warmer because the area covered by insolation is dash, with the responses Y and Z being smaller and greater. Right, here we are looking at, for the perspective of the southern hemisphere, we are saying we are referring to the north-facing slope or the southern slope. The north-facing slope in the southern hemisphere is the one which is facing towards the equator. And if you are looking from the northern hemisphere's perspective, we are saying we are looking at south-facing slopes or the northern slopes in the northern hemisphere. Those are the ones which are facing the equator. So we tend to find that they have warmer temperatures, or they are warmer generally, because the area covered by insolation is greater. There is greater coverage of that slope by insolation because they face towards the direction of the sun. North-facing slopes in the southern hemisphere, they face towards the sun, and south-facing slopes in the northern hemisphere, they also face towards the sun. So basically, the area that receives insolation in those slopes, the area is larger. So our correct response qualifies to be Z for that response, for that question, which is Z for number 121. We go to number 122. Anabatic winds are dash winds. Right, you need to distinguish between anabatic and katabatic. Right, we know those are typical valley winds. It's also a microclimatic environment. When we talk of anabatic, we are looking at the day winds, which are upslope winds. Anabatic winds, they happen during the day. They blow from the valley floor going to the valley sides. And the opposite is true with the katabatic winds. They are night winds that flow towards the valley floor from the valley sides at night. So in this instance, we have defined what anabatic winds are, and we can figure out the correct response from the explanation and the definition of the two types of winds. Anabatic winds are upslope winds. That is the correct response for that one. They are upslope, which is Z. Then we move on to number 1, 2, 3. Anabatic winds are dash pollutants found in the valley. Right, when you talk of an upslope winds and you're talking of pollutants being concentrated in a valley, when there is an upslope winds, it means it takes with itself the pollutants within the valley as it goes up the valley sides. So it means it disperses the pollutants from the valley, which implies that the correct response for number 1, 2, 3 is letter Y. Right, I will move on to number 1, 2, 4. The type of precipitation found in a valley when dew point temperature is above 0 degrees Celsius. We are saying the minimum temperature is above 0 degrees Celsius. In that instance, what type of precipitation forms in a valley? Right, the correct response there qualifies to be fog. Why we are not saying frost? Because frost only forms when the temperatures fall to freezing point, which is 0 and below 0, which means we can only have the formation of frost in the valley at temperatures maximum 0 to minimum of negative temperatures. So that qualifies fog to be the correct response in that instance. We move on to the next question, number 125. Right, number 125, winds at A will be dash than winds at B in the sketch below. Let's try to analyze the sketch. We are seeing those are winds blowing in an urban environment. And where we see our B is falling on an open space, just by the sides of the taller buildings. And our A is falling in within the taller buildings. So, will the winds at A and B comparably, which ones will be weaker or stronger? If we check on B here, there is open space and there is free flow of air and wind flows freely across area B, which will imply that the winds will be less stronger compared to the winds which will blow along channels at A. A is more of a channelized wind which are forced to blow in a given direction because of the barricade or the blockade which is caused by the buildings. So the winds will become stronger as they get concentrated and they get to be channelized towards a given direction. So they become stronger. So in that instance, our correct response is item Z for stronger. Right, we move on to the next question, which is question number 1.2.6. The main factor contributing to the heat island effect in the sketch below. Right, if we check the sketch below here, we can see these arrows which are from one building to the other and back, and to the other building and back. What might be causing the heat island? And remember, when we're talking of a heat island, we are talking of an urban area with a higher temperature compared to the surrounding rural area. What causes higher temperatures in this urban area here in this given sketch? The correct response there is multiple reflections, which is indicated by those arrows that we can actually see. So the correct response there is Y for multiple reflections. Why Z is not correct is the buildings are not of the same height, and if you check the reflections indicated here, they are even higher than some of the buildings on the extreme side. So we cannot qualify height of buildings to be the correct answer for that one. All right, move on to the next question, which is question number 1.2.7. Right, the sketch below illustrates a pollution dome during the, is it day or night? Right, if we check on the shape of the pollution dome and the concentration of pollutants differs between daytime and night time. Right, during the day, because of the higher temperatures within the city, they tends to develop a low pressure system within the city, which will attract incoming winds from the surrounding farmland or the surrounding countryside. So there tends to be a low pressure and rising air within the city because of the incoming air which is fed towards the low pressure within the city. So the pollution dome is elevated during the day. is raised up during the day because of the convection currents that are realized because of the high temperatures within the city that lead to a low pressure that attracts incoming air from the surrounding countryside. So this shape here is typical of the night situation. You can see that the pollutants are concentrated, and also the dome is having a unique dome shape and is just close to the tallest buildings in the city, which resembles that it's a night situation where we have a sinking air which will push the pollutants further down and closer to the buildings, and the concentration you tend to find that it's high at night than during the day. So that one, the correct response is the night pollution dome. It's a night situation. Right, we move on to the last question on that section, which is number 128. The type of pollution dome in question 127 is because of what causes that in relation to convection. Right, convection is low. There are no convections like what has been discussed earlier on. When you have convection, the pollution dome is raised and the pollutants are dispersed up into the upper atmosphere. But when there is low convection, it means the pollutants will become concentrated and the pollution dome will be lowered down. So it means that's low convection for that response. Right, that's the end of question number 1.2. We move on to the next question, which is question number 1.31. That is basically a synoptic, a satellite image on a mid-latitude cyclone, which is likely approaching South Africa. Right, the question is talking about point A here on the synoptic map. Right, you can see if we try to figure out this illustration of this satellite image, you tend to find that we have a cold front on this side here. If we check, there's a cold front which is on this side. We try to illustrate and show how these two are relating. Right, the cold front is coming from this side, and you can see getting to A. Then we have a warm front on this part. That is basically how this weather system is like. Right, so if you can see there, we can try to figure out using the way we read synoptic maps and try to relate it to the satellite images, because basically it's one in the same thing, but it's only that this one is a satellite image. But when we are using synoptic weather map, we use an aerial view where we draw the fronts just like in symbol lines. So what is happening here is the area A, which is marked here, you can see that area A is falling at an area where the cold front has caught up with the warm front. In this instance, we might be having an occlusion at this particular part of the weather system. So the pressure system that develops here, where the cold front has caught up with the warm front, is a low pressure. That is the correct response for that question. That is a low pressure for that response. Right, let's try to figure out the other responses which follow, the other questions which follow after this. Right, the next question is talking about the evidence from the satellite image of your answer to 131. Right, like what I've discussed here, why is it a low pressure cell on that part of the system? Right, you can see also that if we try to use the argument that we were using there of that drawing, you can see that's the point where the cold front has caught up with the warm front, or where there is an occlusion on that part of the weather system. And you can also see based using on the density of the cloud. The cloud there, you can see that there is a dense cloud around that particular area, right, which resembles that warm air has been uplifted from that particular section, causing high condensation level on that particular part. Warm air has been displaced from the ground surface. So basically, that's the evidence that we can use to support that is a low pressure around point A. Then we move on to question number 3, 1.33. Describe the rainfall usually associated with the cloud type at warm front. At the warm front around here, what kind of clouds do we tend to find? Right, maybe if we can try to illustrate this drawing using a cross-sectional view, we can tend to find that we have something that looks like on this part here, we have the cold front, and maybe on this part, we have the warm front going in that direction. And we are saying our weather system is moving in that direction. So we are looking at the clouds that develop along, we are saying this is our cold front, indicated by this, and this is our warm front, indicated by this. We want the type of clouds that develop around this area here, which is the area along the warm front. We know well that around this area, we have incidences of towering cumulonimbus clouds, but that is not where our question is coming from. Our question is solely based on this part here. We want the type of rainfall that is a resultant effect of the clouds that form along the warm front. Right, in that instance, we have light to moderate rainfall over a wide area. The rainfall there will not be as heavy as the rainfall that we receive here under the cumulonimbus clouds. The rainfall here will be light to moderate rainfall, which will be extensive. It covers a wide area and often lasts for several days. The rainfall here will be prolonged rainfall. It's not very heavy, but it's moderate to average rainfall, but which lasts for quite a number of days. Why does it last? Is because this warm front moves gradually, and this cold front is the one that moves faster. So it means clouds will form gradually and will produce rainfall gradually as they are pushed by the coming cold front. And this area will keep on receiving moderate to light rainfall for prolonged periods until the coming of the cold front, which will completely displace the warm and moist air. So the correct response there, we should highlight that the rainfall is light to moderate and covers a wide area and is for a prolonged period. Right. We move on to number 134. Give a reason why the interior of South Africa experiences clear conditions. If we check on this map, the interior here is basically clear. Why is it clear in that instance? Right, we can relate to the coming of this weather system here. If we check this weather system, it's just very close to South Africa here, which means it's likely to impact on the western coast of South Africa. When does that happen? This happens during winter. We have the coming of cold fronts or the mid-latitude cyclone affecting South Africa during the winter season. And that is also where we have to find out that we have clear conditions over South Africa. The reason being that during winter, and we have the dominance of the Kalahari high pressure cell over the interior. We have the dominance of sinking air, which creates stable weather and clear skies over the interior during this particular time of the year, which is the winter season. So basically, the clear conditions are attributed to the Kalahari high pressure cell, which causes stable conditions over the interior and giving us a clear skies. Right. We move on to the next question, which is question number 135. Right. In a paragraph of approximately 8 lines, explain how approaching cold front changes cloud cover and winds experienced at area B. We should make sure that for this question, you address the two aspects in the question. Address the aspect of cloud cover and also address the aspect of winds. Right. With cloud cover, when the cold front is approaching, it will ultimately cause increasing cloudiness of the area. Area B is going to experience an increase in clouds. And as time moves on, the clouds will become thicker and more extensive as the cold front approaches. So it's increasing cloudiness at point B because of the cold front will be coming and pushing the warm and moist air to condensation. And as the cold front approaches, the clouds will thicken. They will become more thicker and they will become more extensive. You need to say they will cover a wider area. And we'll have instances of towering cumulonimbus clouds developing over that area with the approaching of the cold front. That is basically the cloud changes. Then with the wind changes, we are looking at the wind speed is going to increase with the coming of the cold front, and also the winds will become stronger as the cold front approaches. And with the near approaching of the cold front, we will tend to have gust winds when the front is just coming, and that will have a potential of causing harm with the coming of the cold front. That's basically how the wind is also going to change over that particular point B. Right, that is our question number 1.3.5. We move on to the next question, which is a question on tropical cyclone ready. Right, this information provided here. It's an extract, and there is also an illustration of the path that was followed by that tropical cyclone. Right, we won't spend much time looking at the extract, assuming that the extract has been well understood. Right, let's go to the questions. Number 1.4.1. It talks about on which date did tropical cyclone Freddy hit Madagascar. I think that is basically extraction. The answer is there in the extract where it says tropical cyclone Freddy formed on 6 February in the Indian Ocean, northwest Right, tropical cyclone hit Madagascar on 21 February and Mozambique on 24 February. So basically our answer, we were worried about Madagascar. The answer is straightforward from the extract, which implies that the correct response is the 21st of February 2023. That is when it hits Madagascar. Right, number 1.42. Why was the impact of tropical cyclone Fred more severe or destructive in Mozambique than in Madagascar? Why did it cause more harm in Mozambique than in Madagascar? Right, the reason there is the tropical cyclone, if we check, Madagascar is here and Mozambique is there, which will mean that for this cyclone to come from Madagascar to get to Mozambique, it has to cross through the Mozambique channel here. From the 21st of February, when it hit Madagascar, it crossed the Mozambique channel and reached Mozambique on the 22nd of February. So the reason why we are saying because the impact was more destructive in Mozambique is because the cyclone re-intensified, or it went through cyclogenesis over the Mozambique channel. It strengthened over the Mozambican channel, or it went through a cyclogenesis process, which means it gained more power as it was crossing the Mozambique channel. Right, let's go to the next question. Refer to the path of the tropical cyclone. Give 2 reasons why tropical cyclone Freddy changed from a tropical cyclone to a tropical depression from 21 February to 22 February. Right, you can also relate these 2 questions. They are almost related from the way the question are appearing, because you are looking at 21st February in Madagascar and 22nd February over Mozambique. Right, so the reasons why, because we have said it re-intensified over the Mozambique channel. What reasons can we give here? Because we know that a tropical depression is more destructive than a tropical cyclone, which means the wind speeds are different for a tropical cyclone and for a tropical depression. Why is it that the winds were more destructive? And what happened for it to transform from being a cyclone to become a depression. Right, the reasons that you can give there is because of the warm ocean water over the Mozambican channel. Remember, for tropical cyclones, they need warm oceans. So it went through cyclogenesis because of the warm ocean waters over the Mozambican channel, which provided it with energy to revive its power and to revive its circulation and become more stronger and cause more damage over Mozambique. And also we can talk of high humidity. Humidity fuels the cyclones. They strengthen using the power. When they release latent heat, they gain more power. So also because of the Mozambican channel being having warm waters, it also meant that it was fed with high humidity, and which also contributed towards the cyclone being more stronger as it went towards Mozambique. Right, we can move on to the next question, which is question number 1.44. Why is the northwesterly path taken by tropical cyclone Fred considered unusual? Right, before I answer this question, I would maybe want to clarify on the normal path that tropical cyclones form. Right, we know that tropical cyclones, in this instance, in our hemisphere, the southern hemisphere, they move in a direction which is from east to west. And that is the ordinary and that is the general movement path of tropical cyclones under normal conditions. They move from east to the west, right? And why do they move in that direction? It's because they are under the influence of the trade winds or the tropical easterlies. That is why they move in that direction. But if we check for this path here, for this tropical cyclone Freddy, we also tend to find that because of the combined effect of this movement of the tropical cyclones being driven by the trade winds also are influenced by a Coriolis effect, which will also cause them to deflect. And if we try to check or to refer back to our trade winds deflection in the southern hemisphere, we tend to find that our deflection is to the left, which will mean that the tropical cyclone, if it's being deflected with the movement of with the effect of Coriolis force and with the movement of the tropical easterlies, which are also under the influence of Coriolis force, we tend to find them twisting towards the south. But in this instance, it defied that. So why was it unusual? Why is it unusual? It is unusual because the northwesterly movement defies the typical clockwise rotation of tropical cyclones. We tend to find them having to twist slightly to the left or to the anti-clockwise as they get inland over Africa here because of the influence of Coriolis force. But in this instance, it's unusual because it's going against that circulation, that rotation. It's defying that rotation, which means it's an unusual movement of that tropical cyclone. Right, we move on to the next question. Number 1.4.6. Explain how the damage to infrastructure caused by tropical cyclone Freddy could have a negative impact on people in the affected areas. Right, the question here is specific, is referring to the damage to infrastructure and how does it pose negative impact on people. So we need to be very articulate when answering this question. We need to ensure that we indicate what damage to infrastructure has been realized by the tropical cyclone and how it impacts on people in the area. So I'll highlight just a few examples for this instance. We can talk of damage to roads. Roads being a form of infrastructure, the road network being damaged by the tropical cyclone. How does it impact on the people? We can talk of difficulty in transportation of goods or difficulty in access to services. People have difficulties in accessing their services that they want because they need to be transported via the road network, or they have difficulties to access goods that they want because the road system or the road network has been disrupted by the cyclone. Then you can also talk of the damage to houses. Tropical cyclone Freddy caused the damage to houses. How does it impact on the people? it results in homelessness. If people's homes have been destroyed, then it's a problem to the people, them becoming homeless. And damage to buildings, we can talk of damage to buildings like productive buildings like the factories and the industries. That will result in loss of jobs to the people, or that can result to unemployment. That is also a negative implication on infrastructure and resultant effect to people. And also we can talk of damage to communication networks. That can also, a communication infrastructure can be damaged by the cyclone. That will result in disruptions in communication or difficulties in people communicating. So basically we need to be articulate, we need to find the damage that has been done to infrastructure and its subsequent impact to people. Right, then we move on to question number 1.5, which is the last question on climate. All right, the question number 1.5, it says refer to the sketch below which illustrates the development of line thunderstorms and during summer. Right, we should be able to interpret this diagram clearly before we try to answer the question. This is typical of traveling disturbances that happen during the summer season. Right, we understand that this is the interior of South Africa, and over the interior of South Africa, when it is summer, we tend to have the existence of the thermal law over the interior here. Because of intense heating, the ground is intensively heated, and it results in rising air, creating a low pressure over the interior. So we have the existence of the low pressure cell over the interior, and remember we have our two high pressure cells over the Atlantic and over the Indian Ocean, and the resultant effect is that there will be pressure gradient between the South Atlantic high pressure cell and the interior, and also there will be a pressure gradient between the South Indian and the interior. So the resultant effect is that the anti-clockwise circulation of air out of the high pressure cell here will feed into the low pressure cell that has developed over the interior, and also the anti-clockwise circulation from the South Indian high pressure cell is also going to feed over the interior of South Africa, which will be having a thermal low. So those two air masses coming from different directions, apparently they will have to meet somewhere over the interior, and they will create this weather system which is indicated over this interior here. Right, let's not waste time by explaining. Let's go to the questions. Right, we have question number 1.51. Identify the front at A. This front here at A. This is a moisture front. It's a moisture front in that instance because of what happens at this front here. We have incidences of cloud formation and heavy rainfall forming along that front. So it's termed a moisture front. Right, then we move on to the next question. Give the wind direction at B and C. Right, what wind direction is this one and what wind direction is this one? The wind which is fed from the South Indian here from B, let's start from at B here. The wind which comes from B, which is fed from B in this instance, is a northeasterly wind. This is coming from a slightly northern direction and from the east because it's coming from over the Indian Ocean. So it's a northeast, and this one coming from the Atlantic, this one becomes a southwesterly wind. So it's southwest from this side and northeast from this side here. Then state the moisture content of air masses B and C. Right, the moisture content we figure it out from the nature of the oceans from which these high pressure cells are located. This one is located over the Atlantic Ocean, and this one to the east is over the Indian Ocean. So the implication is over the Indian Ocean, remember it's a warm ocean, we tend to have a warm ocean current here, and the resultant effect is that the winds which come from this will be warm and moist. And here over the Atlantic, it means for the fact that it's a cold ocean, it means we have a cold ocean current, and the winds which blow from this high pressure cell will be cold and dry. So when you are comparing the moisture content here, We are saying the winds which are coming from B here, in this instance, the A mass B will be moist or will be humid. And this one coming from this side will be a dry. So it's humid, moist from B, and it's dry from C. Right, explain the formation of line thunderstorms over the interior of South Africa. Right, we'll try just to summarize on that one there, how the moisture front forms. Right, the basic instance is that the high pressure cell over the eastern part, which is the South Indian, it feeds in warm and moist air. And the high pressure cell over the Atlantic Ocean, the South Atlantic, it also feeds in a warm, cold and dry air. Because of its anticyclonic circulation, it feeds in cold and dry air. From the South Indian, it feeds warm and moist air. And the existence of a low pressure cell over the interior attracts these two air masses because of pressure gradient. And they meet along the moisture front. As these two air masses meet, we know well that cold air is denser than warm air. So at the front here, the air coming from the Atlantic Ocean, it undercuts the air coming from the Indian Ocean, resulting in an upliftment of the warm and moist air and formation of clouds on the side of the warm and moist air. So the front forms by that fact that there is air which is fed from the South Indian high, which is warm and moist, and air which is fed from the South Atlantic, which is cold and dry. They meet because of the pressure gradient created by the thermal law over the interior, and as they meet, because of the differences in density and the differences in temperature, they cannot mix. This one is cold and dry from the side, and this one is warm and moist. This one, which is cold and dry, it undercuts or it wedges under the warm and moist. That is how the moisture front forms. And the line thunderstorms will develop as a result of the development of the clouds. As this warm and moist air is forced to rise, it's going to create cumulonimbus clouds that will result in thunderstorms happening along the moisture front in a line, which we call the line thunderstorms. Right, let's move on to the next question. What is the positive impact of heavy rainfall associated with line thunderstorms on the physical or natural environment? Right, the responses here are just simple. We are looking at the implication of having moisture being fed to the natural environment. How does it impact? We can talk of replenishing of water sources, which will benefit the aquatic life. We have different aquatic ecosystems and aquatic life. Those creatures and those animals and plants, they will benefit from the replenishment of water sources. And also it can argue that it adds soil moisture that promotes vegetation growth. That is good for the environment, for the natural environment, that we have the growth of vegetation because of the feeding in of moisture to the ground. Or we can argue that it provides water for the wildlife, which is also part of the benefits to the natural environment. So basically those are the expected responses from our first question on climate and weather. Right, we quickly move on to the second question, which is geomorphology. Right, geomorphology, we are doing fluvial geomorphology. In this instance, we are looking at the study of rivers. Right, I will go through the questions in as quick as is possible. Right, we look at question number 2.1.1. This is a column question. Right, dendritic stream pattern, is it Y or Z? Right, in this instance, we know well that the term dendritic is a derived term from the Greek term dendros, which means a tree and its branches. So when we are talking of a dendritic pattern, we are looking at a pattern which resembles a tree and its branches. So if we try to check on those two patterns, the one that reflects a tree and its branches, we tend to find that is Z in this instance. Our Z is the one which resembles a tree with its branches. This one is now a rectangular drainage pattern on Y. Right, we move on to the next part, which is item number 212. Question number 212. The stream pattern develops on a dome. Stream pattern that develops on a dome, when you're talking of a dome here, we're giving an example of an elevated landscape. For example, a volcanic landscape, where we have a lake on top of a volcanic dome, or where we have that we call a caldera lake, which forms on top of a volcanic mountain. We tend to have streams radiating from a focal point. The streams, they will develop from one source and they will radiate into different directions. So the stream pattern that we tend to find on that instance is radial. Radial, the streams will be radiating from one focal point in different directions. The source being an elevated landscape, and they will be flowing towards low-lying areas in different directions in a radial form, or radiating from a core focal point. Right, we go on to question number 213. Stream pattern characterized by short tributaries joining the main stream at right angles. Right, you are having a situation whereby the tributaries are shorter but the main stream is longer. It resembles an area which is mainly folded, where we have maybe a folded area or a faulted area, where we have a rift valley or a graben and two nearby host or block mountains, or where we have folding, we have two fold mountains existing side by side, and we have a valley in within. The system that we will develop there is that we will have a major river which will run through the valley, and we will have short tributaries emanating from the folds by the sides, or emanating from the block mountains by the sides. So that system that we tend to have there is what we call the trellis drainage pattern. Right, we move on to the next question. 214. The underlying rock structure of the stream pattern below has, what causes this? This type of pattern is typically a rectangular drainage pattern. What kind of rocks contribute towards the development of rectangular pattern? Right, the correct response for that question there for number 214 is Y, where we have cracked and jointed rocks. This pattern is influenced by the cracks of the underlying rocks. The streams will follow the areas of weakness which have cracked, so they will follow those cracks. So the streams, they will be influenced by the underlying existing cracks along the rocks which are below that area. We move on to question number 215. It talks about drainage density of a river system flowing in areas of high permeability. Where we have high permeability, we are looking at a situation whereby the soil or the underlying rock material allows for infiltration and percolation. Rainwater is allowed to filter into groundwater storage. So it means, remember, for us to have high drainage, we need to have high surface runoff and limited infiltration. And if it is the opposite, we have less runoff and more infiltration, it means we will have less streams developing in that particular area. So in this instance, we are looking at a situation whereby drainage density of the river flowing in areas with high permeability, it means there is more infiltration compared to surface runoff. So we tend to have limited number of streams developing in that particular area. So the correct response for number 215 is low. We'll have a low density in that area. We have limited streams. Right, let's move on to question number 216. Question 216 is on stream ordering. Right, the stream order at X. Right, before we even answer that one, let's try to elaborate and try to simplify how we come out with the stream orders. Right, I will try to illustrate and show how we do the ordering of streams in the basin. Right, number 1 plus number 1 is stream number 2. Get number 2 plus number 1 is maintains number 2. We get number 2 plus number 2, it gives us number 3. Then if we have number 3 plus number 1 is number 3, and number 3 plus number 2 is means number 3, and if we have number 3 plus number 3, we get number 4, and so on, going in that order. That is how we do our stream ordering. So I will try to label those streams. Right, a number one stream in a drainage basin is an independent stream without a tributary. So we tend to find that this is number one, and this is number one, this is number one, number one, number one, number one, number one. Those are number one streams in that particular basin. And number one plus number one here means we have number two from this confluence here. And number one plus number one, it means number one plus one here. From this confluence, it means we now have stream number two. And number one plus number one in this instance from this confluence, it means this one is now number two. And let's go back to this confluence here. This is number two plus number one. The order does not change. It's still number two. Then we are going on to number two plus number two in this instance. We are moving on to the next order, which means after this confluence, we have stream order number three. Stream number three plus number two, the order does not change. It remains three here after this confluence. So the correct response here is Z. That is the correct order for that particular point X in that drainage basin. Right, we move on to the next question. Characteristics of first order streams in a drainage basin. Is it straight and short or straight and long? Right, first order streams, they are not long. A high order stream is the one which is longer. Like for example, if we check here, stream order number 3 is starting from here going all this long. But stream order number 1 is just from here to here. Or if we check this one just from here to here, here to there. This becomes a shorter stream. It's straight and short. Right. So the response here is Y, number 1, 2, 7. Right. We can move on to the next question, which is number 2.2. Quickly is on the concept of stream piracy or river capture. Right, it has river R to the extreme west and river Q to the extreme east. Then there's a watershed in between. Then all those processes happening there. Let's quickly go to the questions. We want to answer the questions as fast. Right, number 2.2.1, it says the sketcher illustrates A or N. Is it a longitudinal, plan, oblique, cross profile? Right, this one here, it qualifies to be a plan view. We cannot say it's a longitudinal because the longitudinal profile shows the gradient of the river from its source to its mouth. And in this instance, it's not one river. We are looking at the river R, river Q here, and river S, which later developed after the process of river capture. So this qualifies to be a plan view in that instance. Right. Then number 2.2.2, a river capture is taken place because tributary P flows on dash rock and over a dash gradient. Right, for river capture to take place, we need conditions where one river is flowing, is more energetic than the other river. And the energetic river advances through headward erosion towards the less energetic river across the watershed. It cuts through the watershed and approaches or intercepts the headward waters of the less energetic river on the other watershed, on the other drainage basin. And remember, the energetic river is usually the one which is on a lower ground, which is less elevated. It cuts through headward erosion until it cuts through the watershed until it intercepts the headward waters of the less energetic river on an elevated platform. So in this instance here, if we check our river tributary number P, if we try to figure out using that argument, we can say the nature of rocks. For this river to effectively erode headwardly, it needs to flow over softer rocks. So item number 1 qualifies, we disqualify harder. And what kind of gradient here? The gradient for this river to be energetic, it needs to flow over a steeper gradient. It approaches a river which is high-lying, so that it erodes headwardly across the watershed and be able to reach the other drainage basin. So item number 2 for harder and item number 4 for steeper gradient they are the responses which are relevant to that question, and the combination comes with later option B, which is item 1 and item 4. Right, we move on to tributary, question number 2.2.3. Tributary P, as illustrated in the sketch, is a dash stream. Right, the labels for this water, it just label all the aspects here. river R and river Q. Right, this tributary P is the one which intercepted the headward waters of river Q. So it means this one is the captor. Captor is the one that intercepts the water. Then this one is the captured. And where the stream pirates took place, this particular point here, the bend around here, this is what we call the elbow of capture. Then this river here, which continues after river capture, is what we call the beheaded stream. And then this part here, which marks a gap between the old river which was feeding into this one and the new river starting from here, is what we refer to as the wind gap. So basically, those are the concepts related to stream piracy. We have the captor, the captured, we have the elbow of capture, we have the wind gap, and we have the beheaded stream. Right. So if we're going back to our question, stream P, we have illustrated and we have labeled everything on that particular section of the river capture process. Tributary P qualifies to be the captor. It has captured headward waters of the stream on the other drainage basin. Then number 2.24, the process in which tributary P lengthened its channel by cutting through the watershed is known as, right, the process that aided tributary P to cut through. That, what kind of process is that one? That one is headward erosion. Right, remember we have three basic types of erosion that takes place within the river channel. Right, we have headward erosion. Headward erosion is responsible for lengthening the river channel, is the one that is responsible for making the river longer, which means it happens at the source of the river. The river source keeps on migrating towards the watershed. It migrates, meaning to say the length of the river will keep on increasing. That is headward erosion. Then we have vertical erosion. Vertical erosion is responsible for deepening the river channel. The channel becomes deeper through vertical erosion. Then lastly, we have what we call lateral erosion, which is sideway erosion. Sideway erosion is responsible for widening the river channel. So basically, those are the three types of erosion. So relevant to this question here, our type of process which is responsible for making river tributary P be able to cut through the watershed, it was aided by headward erosion. Right, we move on to the next question. Feature T is known as A or N. That is question number 2.25. We have already discussed that. That bend is called the elbow of capture. Right. We move on to question 2.26. River R will have a dash drainage basin and A or N velocity after river capture. Right. If we check on river R here in terms of its basin, river R used to have a basin which was this side of the watershed before the process of piracy. But now its basin is now extending going towards there, because this part of river Q is now part of its basin, because it's now being drained by this same river here. This is now a tributary of river R, so its drainage basin has been increased by the process of capture. So if we check on the responses here, it becomes larger. And the velocity, how does the velocity of the river, how is it influenced by the process of capture? If there's more water in the river channel, it means the river has more energy. It flows much faster when it has more water. So it's larger and an increase of velocity in that river. So it's the correct combination is item number 2 and item number 3. Item number 2 and item number 3, they come on number 2.26, item option number 6. That is the correct response. We move on to the next question. Refer to area U on the sketch where the river rejuvenation occurred. To answer question 227, 228. River rejuvenation occurred due to A or N and dash erosion that took place. Right, river rejuvenation. Some of the causes of river rejuvenation is isostatic uplift, which is indicated Increase in volume of water, yes, is also a cause. We can also talk of other causes, like an increase in the rainfall received in the area is also a cause or a contributing factor of rejuvenation. But in this instance, our cause is direct. The rejuvenation or the revival of the river's erosive power is being contributed to by the increase in the volume of water. There has been stream piracy, and this stream piracy is contributing towards the increase in the discharge of that particular river, which will also imply that its erosive power is going to be revived. So it's increasing the volume of water, item A. We are cancelling item number 2. Then, what kind of erosion happens if a river is rejuvenated? When a river revives its erosive power, it regains energy to cause vertical erosion. It regains power to erode vertically and deepen its channel. That is why we tend to find that we have the development of landforms like valley in valleys after rejuvenation. The meanders, the entrenched meanders rather. The entrenched meanders, they are a result of incision by the river, which will mean that the river will be deepening its channel through vertical erosion. Or where we have the paired terraces, those terraces are realized because of the development of a channel in the old channel. So it will mean that the river will be regaining its capacity to cause vertical erosion. So the correct response is item number 1 and item number 4. Those two responses, they correlate at item increased volume of water and vertical erosion. Increased volume of water is item number 1 and vertical erosion is item number 3. 1 and 3. Which means the correct response there should be item number A, response A. Right, we move on to the next question. The resultant landform most likely to form after rejuvenation in area U is A or N. Right, let's go to area U and try to analyze what landform is likely to form. This area marked U here, you can see. This river, if you can check, the river is winding, is meandering around this area. So when there is rejuvenation, the river rejuvenates and already the channel was meandering. What is the likely landform that is going to form in that particular part of the river? Definitely the correct response here, we are going to have the incised meanders are forming over that area. Right, that is question number 2.2. Let's quickly move on to the next question, which is question number 2.3. Question number 2.3 is based on the longitudinal profile of two rivers, river X and profile X and profile Y. Right. The first question is talking about what is longitudinal profile. Longitudinal profile, we can simply define it, though it can be defined differently according to your way of understanding, but we should address the basics. I can define a longitudinal profile of a river as the gradient of a river from its source to its mouth. How the river looks like along its course from where it starts until where it ends. That is the longitudinal profile. Right. Then we move on to the next question, number 2.3.2. A is known as this A here. What is it known as? That is a permanent base level. If you can see here, it's starting from the sea level, so that becomes a permanent. That river cannot erode below that point. If it gets that point, it attains a grade. It can never go below the level of the sea where it is feeding into. Right. And give an example of a natural temporal base level of erosion that could develop at the neck point. At the neck point, we can have a lake developing here. It can be a feature of a temporary base level. Right, we move on to the next question, number 2.3.4. Which profile X or Y is graded? When we talk of a graded profile, we are looking at a profile which resembles a smooth concave shape of the river's longitudinal profile from its source to its mouth. So if we try to check between these two, the one which is smooth concave is profile Y. Then we move on to the next question. Give a reason for your answer. I think I've already explained the answer. Why am I saying Y is a graded profile? Y resembles a smooth concave shape from the source of the river to its mouth. And then explain how the profile above the graded profile developed. Right. It is attained because of an equilibrium or a state of balance. For us to attain a grade, it is attained after the river attains an equilibrium. The rate of deposition, the rate of erosion is equated to the rate of deposition, which means whatever is eroded and whatever is deposited is the same, which means the river will maintain a smooth shape throughout its course from its source to its mouth. So basically, when I'm explaining the formation of a graded profile, it is a result of the balance between the rate of erosion and the rate of deposition. The material that is being eroded is equal to the material that is being deposited along the river channel, which will mean that the river will maintain a smooth concave throughout its profile. Then number 237, draw a rough cross profile of the river valley at B. Right, if you check point B here, we are very close to the source. We are still in the youthful stage of the river. If you are drawing the cross profile, you should ensure that your drawing should resemble, let me just simplify, a simple drawing which might be relevant. Right, we are saying the river will be having something like a profile like something like this. Right. What happens with this profile is the profile should have a narrow valley, and the valley should be deep. Those are the basics that should be addressed by that part, because the river is still in its youthful stage. It's still in the youthful stage where it is eroding vertically. It will mean that the river will have a deep valley. The valley will be deep and will be narrow. The river will still be in the young stage or in the youthful stage. So basically, you can draw a profile which resembles something like that. A river which has got a narrow valley and which is deep. That is typical of a river. And also the discharge of the river will be very minimal. It will be having limited discharge because it's just in its youthful stage. Then give reason for the shape of the cross profile. I think I've explained before I answered before getting to the question. The reason why we have a narrow and a deeper valley is because the river is predominantly eroding vertically, and also the river is still in its youthful stage. That is why the river valley is still narrow. There is less discharge in that particular, and the type of erosion does not allow for the widening of the river channel, but rather it concentrates on the deepening of the channel. Right, we move on to the next question, which is question 2.4. Right. Number 2.4 is based on a sketch of a fluvial feature along the river channel. Right, before we look at this, let me try to explain the aspects of this diagram here, so that when you're answering the question, it becomes clear. This part of the river here, this fluvial landform, is what we call a meander. It's a bend along the river channel, which is in the river's lower course. I think you can see that the sea is illustrated here. The river is getting into the sea and it's winding its channel. The channel is winding. In that instance, it's bending. And along these bends, we have what we call the outer bend of the meander and the inner bend of the meander. Right, what we call the inner bend of the meander, for example, is this part here. This part A is what we refer to as the inner bend. And also this part here is the inner bend. And this part here, we labeled B, is the outer, and this is also the outer bend of the meander. So what happens is, as water is flowing past the bend, we tend to have that flow velocity of water here is much faster. The water flows faster. The water which goes via this outer bend will be much faster than the water which goes via this inner bend. The water here will be slower, will be having slower velocity, and the water here will be having a higher velocity. The same happens as the water is going again via past this bend here, there is fast velocity on this part. The water flows faster, and the water which comes via this side will be flowing gradually. That is what happens along the bend there. So this is what we call the outer bend, and which we call, this is the outer part of the bend, and which we call geographically the undercut. It's called the undercut of the meander, and this is called the slip off. It's called the slip off slope of the bend. Yeah, right. These are the two parts of the meander that we are going to look at. And because of the limited velocity here, we tend to find that there is deposition taking place. Remember, whenever the energy to transport a load the falls below the minimum required to transport that load, the river will deposit the load. If the energy required to transport, the minimum required to transport a load is not reached, the river starts to deposit material. So it means there is deposition which takes place here because of the limited velocity of the water, and here, because the water flows fast, it tends to erode this outer bank here. This bank is eroded and is undercut. That is why we are calling it undercut. It means it's being cut by erosional processes happening. And the material being taken here will be deposited on the inner bend where there is limited velocity. That is what happens along the river channel and along a bend in a river channel. So from that discussion, I think we are able to figure out the responses to the questions which will follow. Right, we'll quickly go through the questions and figure out the most probable responses. Right, number 2.4.1. The fluvial landform or feature illustrated in the sketch above. In the sketch is, we have already highlighted the correct response. That one is a meander, it's a bend along the river channel. Then we go to question number 2.4.2. Give a characteristic of a river in the lower course in which this fluvial feature named above develop. We are looking at features in the lower course. What are the features of a river which is now in its old age? Right. The river there will be having a wide channel in the lower course. It's one of the features. It has a wide channel, and also the discharge volume is high or is large. The river has got very large volume of discharge. And also there is slow velocity. The water is generally slow in terms of its velocity. And also, if you can check, the river is shallow. The river becomes shallower because of increased deposition. So basically, those are some of the features that you can figure out. The river is shallow, and there is slow velocity, and also the channel is wide, and there is a larger volume of discharge. Right, that is what happens in the lower course of the river. Then we can figure out question number 4.243. Explain how gradients influence the development of the fluvial landform in the sketch. How do meanders form in relation to the gradient? Right, what you should know that is the gradient of the landscape where the river is going towards its mouth in the lower course. The gradient is almost general. It's general to almost flat. The river will be flowing over a gently sloping landscape. What is the implication of a gently sloping landscape towards the formation of the meander? What will happen is the river will be flowing over a gently sloping landscape, which will also imply that the velocity will be lower in that particular landscape. As the velocity is lower, the river will start to deposit load. We will start to deposit sediments along its channel. And at the end, as the river deposits some material or some silt material and sediments, it starts to wind. It means the river will be blocking its own channel. And as it blocks its own channel, it has to wind to find its way, avoiding the deposits that it has made in its own channel. And as it winds, remember we are talking of what happens on a bend. Whenever the river creates its own bend, it will mean that water which goes to the outer part of the bend will be much faster than water which goes towards the inner part of the bend. And at the end, those processes are going to further and further, and the meander will migrate, the outer part of the meander will migrate, creating a pronounced meander or creating a pronounced bend. Cycles of erosion on the outer bend will continue, and the material that is eroded there will be deposited on the other side. And at the end, you tend to find that the river will create a pronounced bend because of that process. So it starts from the gradient of the landscape, it's gently sloping, leading to low velocity of the river. Because of low velocity, the river deposits material and deposits sediment. As it deposits sediment, it starts to wind, avoiding such sediments. And as it winds, remember there is undercutting that is going to take place as it tries to avoid the load which it has deposited in its own channel. So it means the outer part where it is trying to avoid the load is going to be undercut by erosional processes, and the material is going to be deposited on the inner side where it is avoiding. And that process repeats itself until the river has a winded channel or has a meandering channel which is bended. That is basically how we can figure out how the meanders develop from the gradient of the landscape in the lower course. Right, refer to cross-section X and Y and the fluvial landform features above. Identify slopes A and B. We have already mentioned that. Slope A in that instance, that is a slip-off slope on the inner bend of the river where there is deposition. It's called a slip-off, and slope B is the undercut, which is a slope dominated by erosion on the outer bank of the river. Right. We move on to which cross-section X or Y represents the line between A and B. From A here, we tend to find that this is a gently sloping landscape. It's more of a convex slope from A going to the river channel, and here it's more of a concave which bends inwards. It's an undercut slope. So if you try to figure out from those two, you tend to find that the slope is gentle from beginning at A, it gets into the channel, then it becomes steep as we go towards B. So the reflected cross-section of the channel is the one illustrated by Y. In that instance, is Y from A to B. Right. Which cross-section we've done that one? Explain the process involved in the formation of slopes A and B. I think we've explained that, we just have to clarify. Slope A, which is a depositional slope, which is the slip of water flows gradually on the inner bend, and sediments are deposited on that river spot because of slow velocity. This is the side here. On A here, the water flows at a less velocity and sediments are deposited, meaning to say the slope will be having a gently sloping landscape going towards the stream, the river channel because of deposition. Then slope B. B here, water flows faster on the outer bend, and it causes erosion of the outer bank here. This bank is eroded because of velocity of the water, and it becomes an undercut. Material which is being taken here is deposited here. That is basically how those two slopes form. So we are looking at the process involved in the formation of A. There is erosion and deposition on one side and the other side, and deposition causes that slip off, and erosion causes the undercut on the other side. Right, let's look at the last question on river management, river and catchment management. There's an extract there. The extract, I think, is clear and has been gone through. Right, in which province is Hammanskraal located? Right, this is map interpretation. You can see where Hammanskraal is and the province indicated here, and whatever you can use this infographic to figure out. Right, Hammanskraal is located in Gauteng. It's in Gauteng province. Right, we go to question 2.5.2. What is meant by unplanned development, as mentioned in the extract? The extract is talking of unplanned development. Right. We can safely relate this to a settlement. When we talk of unplanned development in settlement studies, what will we be referring to? Right. Let me try to figure out where the unplanned development part is falling under. Right. It says people have had a decade-long struggle with water and sanitation issues, serving as a clear example of what happens when unplanned development occurs. Right, basically when we're talking of unplanned development, we are looking at urban sprawl, the problem of urban sprawl, uncontrolled growth or formless growth of cities and towns. That is basically unplanned development. Or we are looking at the growth of informal settlements. Or we are looking at illegal invasions of land. That is unplanned development. So basically it has something to do with illegal settling of people, or the sprawling of the urban settlement, the formless growth of urban areas and cities, or basically the growth of informal settlements. That is unplanned development. Then give 2 consequences of unplanned development according to the extract. Right, the extract talks about there are frequent leaks. There are frequent leaks in the water supply or in the sewerage systems. That is one consequence. Then the other consequence is disruption in water supply. Those ones are listed in the extract. It's just extraction. So it's frequent leaks and disruptions in water supply. Then we move on to the next one. How did Apis River become polluted? How did it get polluted? Right, it's also an extract question, which is from the extract given there. The number one cause of pollution is the dumping of raw wastewater into the river. There is the dumping of raw wastewater and also dumping of semi-treated wastewater into the river. Those are the 2 forms of pollution which are contributed to the Apis River. Then the last question, in a paragraph of approximately 8 lines, suggest strategies the local municipality can implement or put in place to reduce pollution of Apis River. What can the municipality do to avoid the instances of pollution of that particular river? We are looking at a legislative perspective. We are looking at the local government. What can they do to try and curb the pollution of the Apis River? Right, we can talk of wastewater treatment improvement. Since we have noted that there is wastewater which is being dumped into the river, what can be done with the wastewater? How can we improve the wastewater treatment system? So we can upgrade existing systems, upgrade the existing water treatment system, or we can do regular maintenance of the water treatment system so that we do not have disposal of untreated wastewater into the river or semi-treated wastewater into the river. That is number 1. Then we can also enforce legislation. We use the ruthless hand of the law to curb the problem. Enforcement of legislation by imposing penalties for violators. We can impose hefty penalties for those who cause pollution of the river. It's also an act which can be implemented. Or we can talk of intermunicipal cooperation. Municipalities can work together with other municipalities in the surrounding so that we manage the very same river which flows through the jurisdiction of the different municipalities. What we call the intermunicipal cooperation. Coordinated efforts of municipalities to try and curb the problem of pollution of rivers. Then we can also talk of private-public partnership. The municipality can partner with private businesses to find solutions to the problem of water pollution, of river pollution. Engaging with private entities, it can also help enhance resources in case the municipality or the local government is crippled in terms of its financial capacity to deal with the problem. It will imply that if they engage private partners, they might also chip in with financial assistance that will help us solve the problem of the pollution of the water sources. And also with knowledge, we might also tend to find that there might be private entities that will cooperate expertise towards the solving the problem of the pollution. And also we can promote public awareness. One of the major reasons why people pollute rivers is because of lack of knowledge on the implications of polluting rivers and the resultant effects of thereof when they pollute the rivers. So people need to be educated on the importance of river conservation and impacts of pollution. It's also a way that can be implemented to curb the problem. Then we can also talk of the protection of riparian zones. We can implement buffer zones around the rivers to limit development close to the rivers. We can fence the rivers so that we limit development close to the rivers, and also we limit unwanted activities happening close to the river. It's also an act that we can put in place along the rivers or along the wetlands. We can buffer.